So we're now going to move into section 1.5 about solving equations. And we're going to look at two different types of equations in this section. But before we get into all of that, if I give you an equation, 5x minus 4 equals 16, no real need to copy this down. The goal is to figure out what x value would make the left side equal the right side. For example, if x equals 2, 5 times 2 minus 4 would give me 10 minus 4, 6. Does 6 equal 16? No. So I know x can't be 2. I want to figure out what x is. Now, I know you know how to solve equations like this. But one thing I'm going to be very particular about is showing all of the algebra. 5x minus 4 equals 16. 5x equals 20. X equals 4. That's not really algebra. That's just sort of magic. I need to see how this line becomes this line, and how does this line become this line. What I'm looking for here is I'm looking for you to show me you're adding 4 to both sides, because that's how we move the minus 4 from this side to the other side. Plus 4 plus 4. I get 5x equals 20. Then you're going to show me divide by 5, divide by 5. You're going to get x equals 4. I know you know how to solve equations. But I'm going to be really picky when it comes to showing the work, because if we start getting into really good habits here, solving equations like this, when we get into more complicated equations like x minus 3 over x squared plus 4x minus 5 plus x minus 2 over x squared minus 3x plus 2 equals 1 over x minus 5, something like this isn't going to be a huge deal because we're so used to understanding the logic behind how one line becomes something else. And if we're so used to kind of focusing on that logic, add 4, divide by 5, and things like this, when we get to equations like this in quarter 4, it won't actually be a big deal. So starting from this section, we are going to make a big deal about showing all the algebra and being very particular with what we're doing. In letter A, for example, we want to solve the equation 2 times x minus 3 equals 4x. We'll start by distributing the 2, and we're going to get 2x minus 6 equals 4x. We now need to get the x's on the same side. I need to show subtract 2x, subtract 2x. We're going to get negative 6 equals 2x. How are you going to finish? By dividing by 2. I'm going to get negative 3 equals x, or x equals negative 3. Remember, the whole point of this was to try to figure out what number you could plug in to make this side equal that side. And if you went and plugged in negative 3, you'd get 2 times negative 3 minus 3 equals 4 times negative 3. Well, this is 2 times negative 6 equals 4 times negative 3. Does 2 times negative 6 equal 4 times negative 3? Sure. Negative 12 does equal negative 12. I found the one and only number that makes the left side equal the right side. You go do letter B. It's going to be a fraction answer. That's okay. Give me an answer as a fraction rather than a decimal, and when you're done, type it into Edpuzzle. What's the answer to letter B as a fraction? So I'm going to distribute the negative 5. 4x minus 5x plus 10 equals 9x minus 14. I'll combine like terms and get negative 1x plus 10 equals 9x minus 14. I'm going to move the x's to the right side. Plus 1x plus 1x. 10 equals 10x minus 14. Plus 14 plus 14. I hope you're showing all the algebra when you're doing this. I will be looking for that in the homework, and definitely when we have a quiz and a test on this stuff. Divide by 10. Divide by 10. I'm going to get x equals 24 tenths, but don't tell me that. Always simplify your fractions, and these numbers are even, so I can simplify down to 12 fifths. Okay. I want you to try letter C. And something a little strange is going to happen in letter C. Try letter C, and then we'll talk about what happens. I'm going to distribute, and I'm going to get 3x minus 12 minus x equals 2x plus 1. I'm going to combine like terms. 2x minus 12 equals 2x plus 1. I'm going to subtract 2x from both sides. Oh, wait a minute. Looks like those x's disappeared on both sides, and I'm getting negative 12 equals 1. Do you remember what that means? If our variables cancel, and we're left with an equation like this, that is a false equation. Does negative 12 equal 1? It does not. That means there is no solution, which means no matter how hard you try, you are never going to be able to find an x value that would make the left side here equal the right side. Go try letter D and see what happens there. I'm going to get 4x minus 3x minus 9 equals x minus 9. I'm going to get x minus 9 equals x minus 9. I'm going to subtract x from both sides. And once again, the x's have disappeared, and I'm getting negative 9 equals negative 9. Do you remember what that means for an answer? If we get something that's a true statement, like negative 9 equals negative 9, or 0 equals 0, or 5 equals 5, we say that our solution is all real numbers. My solution is all real numbers, which means any possible number you plug in for x would actually end up making the left side equal the right side. You plug in 1, it'll work. You plug in 52, it'll work. You plug in negative 3.6, it'll work. Any number you plug in on the left will equal what you get plugging in on the right. Before we move on, I just want to summarize these two special cases. On the bottom of the page, if you get a true statement, something like 0 equals 0, if you get a true statement, something like, for example, 0 equals 0, the answer is all real numbers. And I would like you to write that out in full, no abbreviations. I'm not going to know what ARN or something like that means. All real numbers. You can use the number sign for numbers, but I do need to see it written out. All real numbers. Similarly, and I'll make the video pause after I write the next bullet point down, if you get a false statement, like 1 equals 2, there's no solution. If you get a false statement, for example, 1 equals 2, there is no solution. Take a moment and get those copied down. Everything on this page was an example of what we call a linear equation. Linear equations really just have x's in them, not x squareds, not x cubes, not square roots, no x's in a denominator, no absolute value bars, just sort of simple-ish looking equations, things you definitely dealt with in Algebra 1. In the next video, we're going to see what we do if we have an absolute value equation, absolute value bars in our equation.